In 2.6, we're going to talk about polynomial inequalities, right? So first, let's define what does it mean to have an inequality, right? When we're talking about a polynomial. The way they are written is you have the function, and it's either less than or greater than 0, or less than or equal to 0, greater than or equal to 0. So that's how the function is presented. Now, but let's talk about what those mean, right? So if you look at any function, we've got, if you look at the graph of any function, we've got the x-intercepts or the zeros. The reason why they're called zeros is because the y values are 0 over there, right? And if the function represents the y values, right? Y values and functions, they're sort of, synonymous. If the y values are 0 here, then the function is equal to 0 here, right? We know this. Now, above the x-axis are the positive y values. So anytime the function is above the x-axis, that's when we say the function is positive. So in here and in here, all right, the function is positive. F of x is greater than 0. So notice, right over here at x equals 2, the function is 0. So it's kind of, it's nuanced here. When I say the function is greater than 0, I'm not talking about x equals 2. I'm talking about everything up to x equals 2, like 1.99999. In order for me to include x equals 2, I would have to say f of x is greater than or equal to 0. Does that make sense? Okay. So similarly, in all these other regions here, f of x is negative or less than 0. All right? So to solve a polynomial inequality, we have to solve f of x. We have to plot the zeros on a number line to create what we call a sign chart. Then we have to test values from each interval. We did this a little bit when we were talking about domain, and you had like domain of like x squared plus 3 or whatever. Okay, so let's do that. Now, before we even start solving this, remember how we defined positive and negative parts of a function. We said it's above the x-axis if it's positive, below the x-axis if it's negative. What's the value at the x-axis? 0. So for you to even do anything, you have to compare it with y equals 0, right? So to solve this, we're going to bring everything to the same side. So it's going to be x squared minus 8x plus 15 less than or equal to 0. And now factor this and you get x minus 5, x minus 3. All right, so what are the values that make this 0? 5 and 3. So what we're going to do is we're going to put 5 and 3 on our number line. Now we're going to test values. The easiest way to do it is to plug into this. Okay, so suppose I get, okay, I always start with x equals 0 if it's in one of my regions, so right here, all right? So suppose I get x equals 0. The first parenthesis gives me a negative, right? 0 minus 5. The second parenthesis gives me a negative. Together, that's positive, so this is positive. Okay? Now, in the other region, let's pick 4. 4 will give me minus times plus. That'll be minus. Everybody okay here? Then let's pick like 6, and I get positive in one parenthesis, positive in the other parenthesis. That makes it positive. Okay? So there we go. Now, what is the question asking me for? Go back to when you factored it, right? We want the polynomial to be less than or equal to 0. Less than or equal to 0 means we want it to be negative. We want this region here. That's the region where the function is negative for those values of x. So we say the answer is from 3 to 5. And if this is like a closed circle inequality, right? We're gonna close the limits there. As long as, everything is within the domain. All right, so that's it. That's your answer. So basically what we're saying is, when the x values are within the region 3 to 5, the function is negative. Questions? Okay. Now, let's do this next one. Let's bring everything to the same side. So I get x cubed minus 3x squared minus 22x plus 24 greater than 0. Okay, so guess what? This is not factorable. You can't factor it by grouping either. So guess what we're going to do? The P over Q. So P over Q is plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. So we start doing synthetic division, and wouldn't you know it, the first one works for us. So 1, negative 3, negative 22, 24. Let's see if we're going to get 0.
Wait, what's the P over Q again? Is it like 2 over 3?
The P over Q, they're the factors of this number.
So 8 and 3.
Right, all the factors of this number. 1, 2, 3, 4, all of them. Yeah, over the factors of the first leading coefficient.
Wait, you missed 8.
No, they're in there. So I always go in order, and then, yeah. Okay, so look, it does give us a 0. Isn't that cool? So what do we get now? We get that x minus 1 times x squared minus 2x minus 24 is greater than 0. And that we can factor. What do we get when we factor? What do you guys think? No? Nothing? True. Okay. So now we're going to put this on a number line. But you know what? I'm going to make the process a little bit easier now because I'm going to use things I've learned in the past. So now I have negative 4, 1, 6. I have 4 regions to test. My go-to to start with is always x equals 0. So let's take x equals 0 and let's plug it in to here. Right, when x is 0, I get negative, negative, positive, so that is positive. Everybody okay with this? Yes? Okay, now look, we're not going to plug in any more numbers because we're going to use multiplicities. What happens if the multiplicity of something is odd? What does the graph do? Cross the x-axis. When it crosses the x-axis, it changes from positive to negative and vice versa, correct? There is a sign change. So you go to, okay, so you have your starting point. You go to one of the endpoints of that region, negative 4. You go to the function. Where does negative 4 come from? Here. What's the multiplicity of that? Odd or even? Odd. That means over there it's got to change sign. So it's got to be negative here. It would have crossed the x-axis there. Okay? Now I go to the next region. What's the boundary to the next region? X equals what? 1. At 1, odd multiplicity again. Changes sign. Okay? From here to here, the boundary is 6. Also from an odd multiplicity, it changes sign. So suppose the x minus 6 was squared. Okay? Suppose it was squared. Then here, when the boundary is 6, you're like, oh, 6 has an even multiplicity, so it would have been minus minus over there. Does that make sense? So this is a much, much, much easier way and seamless way, and like we're using the math. Okay, so what do we need here? We want this to be greater than 0, so we get this region and this region here, right? So -4 to 1, open this time, and 6 to infinity, or, okay? Questions? All right.
Yeah, how do you know it's open?
Because it's not greater than or equal to, it's just greater than. All right, next one. X squared minus plus 2x plus 3. Does that factor? No, it doesn't factor. So then, I mean, you can do the quadratic formula. But then, let's kind of stop and think for a minute. Okay? I'm just going to have a number line here, and I'm just going to put 0 there for reference. Okay? All right. Let's think bigger picture. When x is 0, by the way, is that function positive or negative?
Positive.
Positive. Okay. So in the region to the right, when the x values are positive, you would take a positive x value, square it, add it to 2 times it, and then add 3. So that's still going to be positive, correct? Yeah. Okay. In the region when the values are negative, suppose you take -5. Let's just do like a mental exercise. Square it, you're going to get 25. That's bigger than 2 times the negative, so it's still going to stay positive, plus a positive 3. So do you see how there is no way for that to be negative ever? Because whatever number you pick, the square of it is going to overpower double it, right? So it's always going to be positive here as well. So now if the question is asking me, where is this function negative? It's never, so it's no solution. Right? So clearly, this is a parabola that is always positive. Okay? But now, look at this next one. Now I've got the same exact function. Now, it's asking where is it greater than or equal to 0? What would, it's all real numbers. Right? Isn't that cool? Okay, so what about this one? Oh, this one totally factors, right? Because it's x plus 6 squared, actually. Okay? So let's think about this for a minute. Okay, on the number line, I would put -6. And do you see how, like, whatever you put in here, it's going to be squared? So look, it's positive here, right? And then look, here, multiplicity of -6 is 2, isn't it? So it's not going to change sign over there. It's going to be positive on the other side as well. Okay. Now, this is asking you, where is it greater than or equal, where is it less than or equal to 0?
0. Or -6.
It's never less than 0, but is it ever equal to 0? It's equal to 0 at -6. So this will be x equals -6, or you can say like -6 like this. X equals -6 is good enough. So what if I had the same function and now I wanted it to be less than 0? Then that would be what? No solution. And then if I had the same function and now I just wanted it to be greater than 0, not equal to 0, then it would also be no solution. I'm sorry. I'm sorry. I was thinking the other way. Is it all reals?
No.
It's -infinity to -6 and then -6 to infinity. Right? Because it's positive here and here, but it's 0 at -6. It's not positive. Right? It's not greater than 0. It is 0. But then, if I had x plus 6 squared greater than or equal to 0, that's when it would be all real numbers. Okay? All right. So, what we talked about here is a function can change sign at the zeros, right? But does it change sign at every zero?
No.
No, like this one here, that had an even multiplicity, right? So it's negative, negative. It stayed the same sign. So a function can change sign at zeros. Guess where else a function can change sign? At vertical asymptotes. Vertical asymptotes are also a place where a function can start at positive but then change to negative. Again, it has to do with multiplicity, right? If this comes from odd multiplicity, it changes sign. If not, it doesn't. So when we do rational inequalities, we have to do the same exact thing, but in addition, we also have to include the zeros of the denominator. All right? So here, we're first going to solve it as we would anything else. Okay, so take a look at this one. When you have one fraction and then equal to 0 or whatever, to find the zeros, remember all you need is the numerator equal to 0. So x is negative 4 over 3. So in our number line, we're going to put negative 4 over 3. But don't forget any discontinuities. Here there is a discontinuity at x equals negative 2, so I also have to put that there. And now I have 3 regions where I need to check. So let's check one of them. 0 is here, right? So when I plug 0 into this function, I get positive. Is that right? Okay. Now let's do multiplicity. Where did the negative 4 over 3 come from? Here. Does that have odd or even multiplicity? Odd. So it has to change sign there and become negative. All right? In going to the other region, we check the negative 2. Odd or even multiplicity? Odd. Change the sign again. So now I want the regions where this is positive, and that's negative infinity to negative 2. Okay, it is inclusive, so it's greater than or equal to 0. But can I include the negative 2? No, because it's a discontinuity. However, I can include the negative 4 over 3. So those are the sorts of things that you have to be careful of, okay? Huh? So the negative 4 over, okay, we can't include negative 2 because it's a discontinuity. But the 4 over 3 doesn't matter. Okay, next one. Oh, and last one actually. Okay. So I have to solve this one. I can actually solve this one using, what's that thing? Cross multiplication. All right, so let's do that. So x squared minus x minus 11 less than or equal to 3x minus 2. Solve. Yeah, I hadn't distributed first. X squared minus 4x minus 5 less than or equal to 0. X minus 5, x plus 1. Okay? All right, so what goes on the number line? Definitely 5 and minus 1, but what else? 2. That's the most common mistake, is people just forget the 2. Okay, now, here's what's important. Remember what we started out saying. A function is positive or negative in comparison to 0, right? If it's greater than 0. So you always have to compare it to 0, not the 3. So that one, I need to bring the 3 over to this side and compare it to 0, right? Now I plug it in. So let's plug in a 0. I'm going to get negative 11 over negative 2 minus 3. What do you think? Is that positive or negative? Positive, right? Because that's positive 5.5 minus 3, so that's positive. So what did I plug in? 0, that's from here. That was positive. Okay, and then the rest we're going to do the same way. Multiplicities, right? So here, in crossing to the right, 2 comes from odd or even multiplicity? Odd, so it's gonna change sign, yeah.
Why can't we plug in the numbers into the x minus 5
Because when you plug it in over here, you've eliminated everything with the denominator and everything, like you've changed the problem too much, right? Okay, so in the rightmost region, is it going to be positive or negative? Positive, because the 5 does come from, what do you call it? Odd multiplicity, and here it's going to be negative, same reason.
Wait, so this is an odd multiplicity?
Huh?
Is this one an odd multiplicity?
Yeah.
So like when it's an odd multiplicity, we're just like comparing the
So
X squared.
for the odd multiplicity, you say, okay, where did this 5 come from? Here.
Yeah.
That has a exponent of 1, which is odd.
Right.
So that's an odd multiplicity. It means in going from here to here, it's got to change sign.
Okay.
Okay? Yep.
How can 0 be a positive because don't the 2
They do. So this will be like 5.5 minus 3.
Oh, I thought
That's positive. Yeah. Okay. So what region are we taking? Less than 0. Oh, less than or equal to 0. So here to here. All right. So what do we say? What's the answer? Do I include negative 1?
Yes.
And? Correct. All right. That's it. That's the answer. Okay? That's the lesson. Okay. So